So I've been trying to do this presentation for like, I would say about 5 months now. Rich, does that sound about right? I think the first time we did it, we got snowed in, and every time since then, something has sort of knocked it off the docket, which is just fine, because every time I get knocked off the docket, me and Rachel at this point go in and actually just keep modifying this and trying to make it better and better. So hopefully it's worth the wait. If it's not, I'm sorry, I apologize. So what we're going to be focusing on today is 3 acts and 9 key concepts for understanding Dax. Okay? So, from my perspective, there are 9 related concepts whose understanding will help you transition from a novice to an intermediate Dax user. Understanding each concept in isolation is not terribly hard. The trick is holding all 9 of them in your head together at once. My goal here is to present all 9 in such a fashion as to help you relate them all together. Okay, so you can sort of see the whole picture. In addition, there's several important Dax concepts I've left out. I've left them out because I think that they're easier to understand once you understand these 9, okay? That's why these I consider to be the core concepts. Other concepts are super duper important. If you want to be a Dax expert, you have to learn them, but you could sort of push them off just for a little while to sort of understand these 9. Then when you get to those other more difficult concepts, they will make quite a bit more sense, okay? Concepts presented here include both simplifications and some added terminology. My goal here was to convey the essence of things while remaining technically very close to the mechanics and the reality of what's happening. More nuanced versions of these ideas you will need to learn once you move forward, but today, if you're sort of newish to Dax or an intermediate Dax user, I think this is a great version to start with and try and just wrap your head around the entire idea of Dax with these 9 concepts. Okay. Does that sound good? Okay. Oh wait, nope, I got more stuff to talk about. At its heart, Dax is very simple. I hope that simplicity will be revealed in the following slides.
Can I interject also?
Please do.
So these are really pillars that Brian has kind of feels has sort of digested down from all the learning that we've had about Dax that you could return to again and again as reference for the more complicated concepts. So they're actually extraordinarily rich. I have to tell you, they kind of blew my mind when I first saw them because I thought, wow, that is a slightly different way of seeing it. But the more I've worked with it, the more impressed I've been. So if you think of these as 9 pillars, I would love to, at the end of it, or at any point, to say, for you guys to say, yeah, that I could see how that would be a pillar. And it might take a while to digest it, but I think the spirit of the thing was really everything else that follows can build on these foundations.
Correct. Yeah, and so apropos to last month. I would say I started working on this, I think I looked it up about 6 years ago. I actually found the date when I read Jeffrey Wang's blog on many-to-many relationships. If you ever get the chance, it is a fantastic blog on Dax. What's great about that blog is that it's completely packed with information, okay? So when I read that, I had no idea what he was talking about. I read it again, I still had no idea what he was talking about. I read it probably 50 times in the course of 3 weeks, and by the end of those 3 weeks, I would say I advanced 6 to 9 months in my ability to understand Dax. Okay? I don't think I achieved that here today, but my goal was to have something with a similar depth to reveal the same kind of ideas. So I don't expect people to watch this once and grasp the whole thing. I want you to grab parts of it, but what I really want you to do is to be able to go back and review it and say, okay, let me sort of view this over and over and over again and get those YouTube hits up. And then I could really understand the whole thing at once. That's what I hope for. Okay, enough talking.
I can't help when I see that first phrase there of Alberto's words, and you know what I'm talking about. The Daxa is a simple.
No, it's a beautiful language.
Yeah, but it's not always
simple, but it's not easy.
Not always easy.
That's right. Yeah.
It's like a beautiful woman.
Yeah.
You will never.
No, that's calculated.
Okay, so Dax in 3 acts. Act 1, tables. Act 2, measures. Act 3, iterators. Let's start with Act 1. Okay. So core concept number 1. Summary tables are the fundamental things that the Dax engine builds. These tables are the numbers behind every single visual inside of a client tool like Power BI. Everything else in Dax is in service of building these. I'm going to try and stay close to the podium, but I can't help myself. I'm going to migrate over here a little bit. So whenever you've got a visual in Power BI, right, there's always a summary table behind it. So if you have a chart that has sales broken down by category and broken down by city, you need to have some summary table that has category and city and sales for each one of those things, right? Conceptually, that makes sense, but you may not have thought about it up until now. Does that conceptually sort of jive with folks? Okay, this is what Dax builds. Everything else that you do in Dax is to build these things, okay? Now, these summary tables basically have two kinds of components in them. They've got category columns, which correspond to business contexts or groupings, things like city or category or year or customer name. And then you've got measure columns. These correspond to business questions, which is sort of like aggregations. These would be things like total sales and margin percentage and year-over-year sales, things like that. Okay? So whatever visual you're building in a reporting client like Power BI, Dax is always building these summary tables to create those visuals. Okay. Am I missing anything, Rachel? Okay. So, yeah, she will. So every single visual is going to have a summary table behind it, okay? So if we've got these three visuals over here, each one of these visuals, Dax is building a summary table in order to create these lines and that number and this matrix right here, okay? So if we see right here, we've got total sales and total margin broken down by year and quarter. Well, sure enough, we need a summary table with sales and margin broken down by year and quarter. If we've got total sales broken down by city and category over here in a matrix, we need a summary table with total sales broken down by city and category. Okay? Now, what happens if I click on one of these slicers? First off, do the visuals change? Yeah, the visuals change, right? And when the visuals change, Dax goes and builds new summary tables. Okay, so whenever you interact with a report, Dax is building new summary tables. Okay? So our goal is to make sure those summary tables have the right things in them. Okay, so in Jeopardy, all answers must be in the form of question. In Dax, all answers must be in the form of a table. You cannot ask the Dax engine a question and have it return an answer that isn't a table. It's impossible. If I want to ask Dax something ridiculously simple like, what is 2 plus 2? I can't actually ask it that. I have to go say, hey, could you give me a table with the question 2 plus 2 broken down by nothing? Right? That's how it would get an answer for that very simple question. That's all it does. So because decision makers almost always need to see answers broken down across category combinations and filter to specific subsets of the data, Dax is going to be built from the ground up to be optimized for doing this specific tasks, which is to say, it only answers in tables. So if you try and look at cells in isolation and try and figure out, hey, how is the Dax working for this particular cell, like this cell right here, but you don't think of it in terms of the context of the rest of the table, you're going to get confused very, very quickly. If you want to understand how Dax works, remember, every single calculation you're looking at has to be performed in the context of a row inside of a table. Still making sense? Good. Okay. Concept number 2. Dax works by creating derived tables from the data model. Okay? Most often these temporary tables are filtered by active filters and contain all of the columns of a table. You're never going to work with the model directly, so you only work with these derived tables. So if I've got a summary table over here where I've got total sales broken down by year, right? To get this summary table, Dax is actually going to derive 3 other tables from the sales table in the data model. Okay? So if I've got fact sales over here and I want to get these 3 cells right here, Dax actually gets a derived version of fact sales for just 2018 beverages, a derived version of fact sales just for 2017 beverages, and a derived version of fact sales just for 2016 beverages. Okay? So when I have a measure like total sales equals sum of fact sales sale amount, okay, you might think that what we're adding up is a sale amount column here in the fact sales table. We're not. We're actually adding up the sale amount column in each one of these new derived tables. So you might be asking, well, wait, Brian, I've got a summary table that has 500 rows in it. Am I deriving 500 different copies of the fact sales table? Yeah, you are. That's exactly what you're doing. Questions about this? Okay. So when I say derive a table, I mean we're sort of getting kind of a version of a table from the data model. And if we imagine that we've got this table right here, let me zoom in a little bit so you can see it. This is the Dimm stores table, right? If we were to ask ourselves what kind of derivations can we get from that table right there? What kinds of tables can we pull from it, right? There's 4 major different kinds that you will work with over and over and over again. There's other ones too, but these are the 4 that are going to be your workhorses. This is where you're going to spend 90% of your time. Okay? So when you get one of these derivations, you can either get all columns or just one column. And you could have it respect the filters, or you could have it ignore the filters. Okay? So if I've got dim stores right here, and in a measure, in an expression, I just ask for dim stores, what I get is a derivation of dim stores with all the columns, but respecting the filters. Right? This is what you use most of the time. By contrast, if I want to, I could say, you know what? I want to get dim stores, but I want to get all dim stores. Okay? If I use this bit of code right here, I get a different derivation. I'm going to get all the rows and all the columns in dim stores, because I'm ignoring the filters. Now, what if I don't want all the columns? What if I just want one of the columns? So let's just say I want all the distinct cities that are visible right now. I can say, hey, I want to go get values of dim store city. And if I do that, I only get one column, just the one single column that I asked for. But do I get the filtered version or the unfiltered version? I get the filtered. If I want the unfiltered version, I use this bit of code right here. All dim stores city. Okay? So these are the 4 tables that I can get in DAX at any given moment. So let me ask you a question. How many dim store city columns are on this page right now? Is it 1? He asked pensively. No, it's not 1. There's 5. Okay? So for every single one of these derived tables, every single one of them has a dim store city column in it. So what that means is if you're looking at a bit of DAX code and you see dim store city, you might think that what you're pointing at is the city column, right, in the stores table in your data model. You're not. You're pointing to some column in a derived table. You could be pointing at this one, you could be pointing at this one, you could be pointing at this one, you could be pointing at this one. Okay? So what that means is the name of a column doesn't tell you what table it's in, it only tells you what table it's from. Still making sense? Okay, good. So what do I do with those things? Well, I could do a lot of different stuff, but to keep it simple, let's just say I just want to go get the total number of stores, filtered and unfiltered, and I want to get the total number of cities, filtered and unfiltered. I could have these 4 measures right here: total filtered stores, total unfiltered stores, total filtered cities, total unfiltered cities. And each one is just to count rows of some different derived table. Here on the top one, it's just dim stores, right? It's the dim stores table with filters applied. Right here, it's all dim stores. So it's the dim stores table with no filters applied. Here we got values dim store city, so we just want all the distinct cities that are visible in the filter. Here we've got all dim store cities, so we want all the cities regardless of what the filters are right now. And if I do a count rows of each one of these derived tables, I get different answers, right? Sure enough, I get 4, 6, 2, and 4. Because in this table I've got 4 rows. In this table I've got 6 rows. In this table I've got 2 rows. And this table I've got 4 rows. Still making sense? Good. Okay. Number 3, in DAX, even filters are tables. So in English, you might say something like, I want to filter for year equals 2017. You can't ask DAX that, not directly. So in DAX, if you want to filter for year equals 2017, what you have to give it is a table that has one column in it called year and one value for 2017. That's what a filter looks like in DAX. So if I've got a slicer like this one right here, right, where I'm slicing on month, and I've got January, February, and March selected, this is producing the filter that looks like this. Okay? This is the filter that says, just give me the months of January, February, and March. That's how you say that in DAX. Okay? Over here, if I've got Beaverton and Vancouver selected, I get this filter, right, on city. City equals Beaverton or Vancouver. This is how you say that in DAX. Still making sense? Okay, so when you're building your own filters, it's going to be much easier if you keep in mind that what you're building is tables. You may think to yourself, I just want to look at beverages. I just want to look at Vancouver. That's fine. As soon as you have that thought cross your mind, the next thing that crosses your mind needs to be, how do I make that appear as a table? Because DAX only thinks in tables. Okay.
Question, Brian.
Yeah, sure.
So earlier, in your earlier example, you were saying that there were actually 5 separate tables, which would suggest that there are 5 copies of that data in physical tables.
Have you been talking to Rachel?
Not well. I have been, but we haven't been talking about this recently. Yes. So I would have to believe that that means that those are virtual concepts.
Yes.
And that it uses some kind of pointer magic to not necessarily materialize 5 separate copies.
We had a long discussion about this. The term I used before was copies of a table because that, to me, was the easiest to think about. Sure. And then we had some discussions with a friend of Rachel's and was like, that's not how they work. And I'm like, well, all right, but like it's so much easier to understand. But he's like, that's not how they work. And I said, okay. So if you come from a SQL background, you're not physically copying the tables. You could think of them more like views. If you don't come from a SQL background, don't worry about it. Think of them like copies. Okay? If that doesn't make your head go, how does it perform? Don't worry about it. If it does, think more views, right? But the most important part is, as far as Dax is concerned, they are tables, right? And they are derived from tables in the data model. But you never work directly with the tables in the data model, only through derivations.
So when he first said this to me, I'm like, why do I care? Why do I care? Okay, it's a copy, big frigging deal. Yeah. And one thing I sort of said to myself, well, okay, if I was writing an Excel, trying to figure out something in Excel, I would maybe not mess with the source data. I'd make a copy of it, right? And then I'd manipulate it around. And I said, well, Brian, is that the reason it's such a big deal, that it's a copy of a table? And so I would like to hear you say exactly why I care, that that it's a copy of a table, because he's got a good answer.
Oh, I do? So, there could be several answers for this. In my mind, the one that it makes the most sense, because it's the thing new people butt up against the earliest, is they will see a formula that references the date column. You'll have two references to the Dimm dates date column in the same line, right? And there'll be an equality. Say, hey, does Dimm dates, is that greater than or less than the equal of max Dimm dates, right? And you'll think to yourself, well, wait a minute, doesn't a column have to be equal to itself? How is it possible that I could have two values with the same name? Aren't they always going to be equal? The reason they're not equal is because you're talking about two different columns in two different tables, right?
And this is an incredibly, for those of you that don't know Rob Colley's work, this is the greatest formula in the world. This is one of the most important patterns in Dax, which is time intelligence-based patterns that has this very confusing kind of where clause, where it says, the max date is equal to the max, where the max date is not equal to the max date or less than equal to, and it's like, what are they doing? And that's really because it's talking to a copy of a table. So that's one good justification.
Keep talking, I'm trying to write it right now.
Yep.
Go on about something for a second.
So, one other thing because I also like this huge emphasis on tables, like a filter is a table. I'm like, okay, well, like I'd much rather think of a filter as a where clause, right? Because I can understand that. Part of the reason to me that, well, why don't you go ahead now that you've done it? Just filling in time.
Smooth transition right there. All right. So there's other stuff in here that we'll get to later on, but this is the formula that you show these people and say, this is the greatest formula in the world, and they say, why? It doesn't make any sense. It is the most powerful formula in the world. It's awesome. This is a great pattern to learn as a new person, but you basically you memorize it and you stop asking questions about why it works very quickly, right? What's confusing about this? We filter over all Dimm dates. Okay, I'm a new user. I kind of get that. I go get the whole date table, right? And what do I check to see? I check to see if Dimm date's date is less than or equal to the max of Dimm date's date. Wait a minute. Dimm date's date. Dimm date's date. How could they possibly be not equal? It's the same value, isn't it? The reason is, and this is kind of a trick of Dax that we'll get to, this Dimm date's date column is actually in a whole different table, right? So for every single row in Dimm dates, this gets a whole different copy of the Dimm dates table that has different values in it, which is why these two things could be different. Okay? And if you don't understand that, you just get baffled by this.
So when Power BI was very, very new, in fact, this may have been Power Pivot way back when.
Yes.
The community was so small that to learn Dax, we just there were members of the community. We just emailed each other, and Rob Colley was one, and the Italians were very involved. And I remember struggling with filters, and I didn't get it, and I was frustrated because I wanted so bad to get it, and I couldn't get it. And I was trying to do something like this, and I remember Marco fixing my code, sending me this, and it was probably a min or something similar. Yeah. And I said, but Marco, why does it work that way? Tell me why. And he said, it doesn't matter. It just does.
That's right, yeah.
It angered me.
Yeah. Oh, sure. And part of the idea of this whole presentation is basically to illuminate this.
Yep.
Why does this thing work, right? How does it work?
What is it returning?
So this is actually returning a table. So what this is going to do, and we'll get into it. So again, everything in Dax is tables, right? So this bit of code right here returns a table. This table is going to be all of the dates where the dates of this table are less than the biggest visible date in some other table.
Like a cumulative total is usually
Yeah,
when it.
but
That's
if you
right.
went and sliced on Dimm date's date, it would be that value that you sliced on, or the
Right.
upper range of the thing that you sliced on.
So let me increase our confusion by jumping way ahead. So when you write max of Dimm date's date, this is the actual function. So that's syntactic sugar. This is what actually gets written. Okay. So filter gets this table right here, right, and adds. Oh, I'm getting way ahead of myself. Suffice to say, this Dimm dates right here belongs to this date table, right, which doesn't have an all wrapped around it. This date belongs to this date table, which does have an all wrapped around it. Okay. All right. If you're excited, what's that? This is probably a good one. Okay. If everybody already gets this, we could just stop the whole presentation. Should we keep going? All right. I worked really hard on it, so even if you get it, please lie. Okay. So let's pop over here. All right. I think everybody. Well, wait. Let's review. So everybody gets this. There's basically 4 different kinds of tables that you could derive. You can get one column. You can get all the columns of a table. You can get a filter. You can get it unfiltered. And if you count it, you get these kind of results right here. You get different numbers because you're looking at different tables, right? Even though we're looking at Dimm Store City and both of these right here, because we're not ignoring or ignoring the filters, we get different results. Conceptually make sense? All right, let's keep on walking through it. Number 3. Oh, I think we already did this one. Yeah, in Dax, even filters are tables, right? So if you've got a filter in Dax, you want to say, hey, I just want to look at Beaverton and Vancouver, you have to think to yourself, how do I produce a table that looks like this? Because that's what the filter is going to be for just show me the cities of Beaverton and Vancouver. Okay, keep on going on. All right, so if we sort of change our old visual just a smidge, we can get a better sense of how this thing works. So if we've got a summary table right here, right? And by the way, what is the fundamental thing that the Dax engine builds? What is it always building? Which kind of tables? It's always using derived tables to build summary tables, right? Everything's always in service of this summary table right here. All this other hoopla over here is to build this table right here, okay? So to build this table right here, we've got total sales broken down by year. What the Dax engine is going to do is it's going to get 3 derived fact sales tables, right? This one, and this one, okay? So we've got the fact sales table in the model right here. We want to get this fact sales table, this one, and these are filtered. How are they different? Well, this one's looking at 2018, this one's looking at 2017, and this one's looking at 2016. All for beverages, right? That's the way it should be, okay? So how do these derived fact sales tables actually get filtered? They get filtered by the filters in something called the filter context, which is to say all of the active filters. Okay, so let me zoom in here so you can see this better, right? For each one of these cells, right, there is a different filter context, which is to say there are different active filters. So for this cell right here, let me zoom up a little bit. For this cell right here, right, we're going to need a filter for year equals 2018 because that's what the row says. And we're going to need a filter for category equals beverage because that's what the slicer says. That's what an end user expects, right? So sure enough, here in the filter context, the active filters, we've got a filter for year equals 2017 or 2018 and a filter for category equals beverage. So when I ask Dax, hey, go sum up the fact sales sale amount column, right? It goes and derives a table. And when it does it, it filters it by this and this for this cell. For this cell, it filters it by this and this. For this cell, it filters by this and this. Okay? So how many different tables do we have on this page? Gosh, we have a lot of them, right? We've got the summary table. We've got 3 derived tables. We've got 6 filter tables. And we've got a single table in the data model. Tables, tables, tables. There's a reason they call it tabular modeling, right? This is all about tables. Everything on here makes sense. Okay, anybody want to come up here and redo that? No? Okay. So the careful reader, careful viewer, might ask the question, hey, wait a minute, I've got really good glasses. I've got remarkably good glasses, and I can read, and I can see that the category column doesn't exist on this fact sales model, right? So in this fact sales model, I got a bunch of stuff. The one thing I don't have is a column called category, because category is off in the products table, a whole different table. So how is it possible? How is it possible that a filter on a different table is it affecting the derivations from the fact sales table? Relationships. Good. Exactly. Relationships. Relationships is what make that happen. Okay. So if I've got a filter in here, right, and this fact sales table has a relationship to the in this case the product table, and in this case the date table, these filters will act upon the derivations. If that relationship doesn't exist, what will it do? Absolutely nothing. Question?
So, Brian, when you have relationships between tables,
Yes.
before you create any DAX measure,
Yes.
has a derived table already been created of those relationships combined together?
No, derived tables, which is, by the way, my invented word. So if you go talk to people at Microsoft, they'll have no idea what you're talking about. Derived tables are created at evaluation time, right? So when DAX goes to build the summary table, right, the first thing it does is it gets basically a grouping of all the different category combinations. Then it goes sort of cell by cell to build out all my different numbers. And for this cell right here, it says, oh, to get that number, I have to go derive the fact sales table. It derives it, sums up one of the columns, sticks the number in. Then it goes to the next cell. It says, oh, I need to go get the sales table. It does other stuff, which I'll show you in a second.
So
Does that answer your
what you say there is, before any DAX measures are created,
Yeah.
there is no massive flat file
No.
within Power Pivot or Power BI.
Absolutely not.
Okay.
Absolutely not. Yeah.
All right, thank you.
Okay.
But
Ooh, I know you want to talk about it. I thought about putting it on here too.
I just don't walk completely away from that concept, because expanded tables is a very, very important concept, and we're sort of skirting around that because it's not like it goes and, okay, I'm going to mush it all together in the very beginning before you even create a DAX. But expanded tables is very important.
So if you like the idea of relationships, but they seem like magic to you, and this all seems like easy to you, go look up expanded tables. That's how relationships, that's the mechanics behind relationships. If that sounds like something that's way above your head right now, don't worry about it. All I need to know is relationships let filters from different tables affect a fact table, right? Everybody still with me? Okay. Keep on going. So, for Act 1, what do we got? Tables, tables, tables. Summary tables are the fundamental things that the DAX engine builds, number 1. Number 2, DAX works by making derived tables from the data model, okay? So if I've got a summary table over here, I might have 50 derived tables to create this single summary table right here. DAX does it very fast, does it very effectively. In DAX, even filters are tables. So whenever you're thinking about a filter, it has to be in the form of a table, okay? All right, so let's talk about measures, shall we? Measures correctly answer a business question by using filter refinement, okay? Filter refiners modify the active filters to get them correct. Then they run some code under the new filters, okay? So if I look at this cell right here, let me zoom in on this right here. So the number is 13 million, blah, 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 blah. How would a user interpret this? What does this number mean? What does it correspond to? 2017 sales for what? For premium beverages. Why? Because it's in the row premium, and it's got the category of beverage selected. Why 2017? It's the name of the measure, right? That's what it should be. That's what a user expects. Okay, so if a user opens up this formula, this number better darn well correspond to 2017 sales for premium tier products that are beverages. That's what the user expects. However, when this cell starts evaluating right here in this summary table, how many filters are actually currently active? Just one. Just the one for category equals beverage, because this is coming from a slicer. It's coming from outside the summary table, if you want to think of it that way. Okay? So when this cell starts, the only active filters are beverage. Through some process, we have to get the filters to category equals beverage, like before. We also need to add a filter for tier equals premium and year equals 2017. Does it make sense that these filters need to be in there to be getting the correct answer? Good. So filter refinement is what does that job. And the measure is a filter refiner. It changes the filters to be from looking like this to looking like this. That way we can answer the business question correctly.
Filter refiners.
This is really what
That's another one of my made-up words.
This is
yes.
what made me start to cry when he called measures filter refiners.
It did.
I thought I'm a complete moron because it's such a different way of looking at it. Most people who teach DAX tend to say you got an aggregator, you got an iterator, and the truth is the function itself inside it, sum, might be an aggregator, but the measure is doing something very different. So this, to me, is the most mind-blowing and probably the most important, for me, contribution in this pack, which is think of a measure as an answer to a business question, and it's actually refining the filters that are showing up all outside. And that's a big mind transition. For me, it was. Anybody else have a struggle understanding that? No, they all get it.
They all get it, yeah. That's why it's so good.
Nobody needs to cry.
Trademark it.
That's right. Real quick. Yeah.
All right, we got this on video, right? Okay, so what do measures do? Well, they answer a business question. Yeah, that's what they're sort of, they correspond to a business question. Total sales, margin percentage, year-over-year sales. But how do they do it? What are the mechanics behind it? Measures do two things. They refine the filters, and then they run their code. Don't forget they always do both. When you define a measure, you're probably going to remember the second one. When I said, hey, I want to go get sales for beverages, I wrote some formula for sales for beverages. I probably remember that formula part. What you probably forget is before it runs that formula, it refines the filters. That's the very first thing it always does. Okay? And I could tell you, irregardless of what's in these measures right here, how do they work? They all work the exact same way. They refine the filters, and then they run their code. Total sales refines the filters and runs its code. 2017 sales refines the filters, then runs its code. Margin percentage refines the filters, then runs its code. Average product line sales refines the filters, and then runs its code. Always, 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 those two things. Okay? So filter refinement consists of two phases. That's what we're going to explore next. So how do we get the filters just right? How do we get them to that Goldilocks condition? Okay? So if we imagine these two cells right here, right? We've got total sales, right, in this table for here and here. So what filters need to be active for this cell right here? Let me zoom in. If I'm an end user, what filters am I expecting to be active to get that number right there? What does that number represent?
Somebody whispered the correct answer.
Total sales for beverage in Washington.
That's right, yeah. Not a trick question, right?
If it tricks the user, you've not done your job, right? It should be simple. Within the premium tier. Within the premium tier, very good. Okay. So what filters do we need? Tier equals premium, state equals Washington, category equals beverage. So somehow we have to get the filters to this stage right here. And the first step of that is what I call current row filtering. You may have heard this called context transition. That's a more technically slightly, well, I don't say slightly. It's a more technical definition of it, probably a little bit more accurate. How do you think of it? Current row filtering. What does current row filtering do? It filters to the current row. That's why I call it current row filtering, right? So filter refiners start getting filters correct by performing current row filtering. And often this by itself will be plenty. This will get the job done. If we look at this table right here, for this cell, we've already got a filter for tier equals premium. That comes from the slicer. That comes from outside of the summary table, right? And then the measure, when we run total sales, before it runs this code, it refines the filters, right? And the first bit of filter refining it does is performing current row filtering. What's in the current row? State equals Washington and category equals beverage. The measure adds these two filters right there. By the way, what does it do after it adds those filters? Runs the code. Refine the filter, run the code. Refine the filter, run the code. Okay? Same right down here. If we've got this cell right here, what are the correct filters for it? Tier equals premium, state equals Washington, category equals food. Okay? The slicer provides this filter right here. The measure adds this filter and this filter through current row filtering. Does that make sense? Okay. So the nice thing about current row filtering is the definition of the measure doesn't matter. It always performs the same way. You can almost ignore what's in the measure itself, right? For any measure, current row filtering just takes the values of the current row and adds them as filters. For this cell right here, it adds premium. For this cell right here, it adds Oregon and walk-up. Oregon and walk-up. And for this cell right here, it adds size equals large. Okay? So I just want to take a second to really point out that for a lot of instances, for most simple measures, this gets the job done, right? This is why when you write a simple measure like total sales equals sum of the sales amount column, it works everywhere you want to use it, because for every single cell that it's in a summary table, it's taking the values of the current row, it's adding them as filters, and then you get the right answer, like magic. This is how it works. Okay? However, what happens if you have a slightly more complex measure, like 2017 sales? Okay? So to get 2017 sales, if we start with filters like this, we need to add filters for tier equals premium here. We need to add the current row. If we add the current row, that gets us pretty close, but it doesn't get us all the way there. Doesn't get us all the way there. If I want, for this cell right here, for this cell, if I want, assuming this slicer is selected, this cell, what filters need to be active for this cell right here? Category equals beverage, tier equals premium, and year equals 2017. Okay, so the slicer takes care of category equals beverage, no problem. The current row filtering takes care of tier equals premium. Good, that's handled. However, to get this right, we need a filter for year equals 2017. That's the only way this is correctly going to answer that business question. Okay? So if current row filtering isn't cutting it, you can move on to something else. Item 6, filter refiners finish getting filters correct by applying optional override filters. Okay? So when the current row filtering doesn't get the filters just right, you can apply override filters to finish the job. So for instance, just like we had before, here we've got 2017 sales for Washington and walk-up, and for beverages. The slicer provides beverages, current row filtering provides state, and layout equals Washington and walk-up. But if we look at the measure, 2017 sales, what's the actual definition of this measure? It calls total sales, right, another measure, and says, hey, when you go get total sales, I want you to add a filter for year equals 2017. This is an override filter. This says do the current row filtering, that's still important, but after you've done the current row filtering, add this filter too, because that's how I line up the filters with my business question. Okay? Now, you can't actually paste a PNG into your DAX code, right? So how do you actually get this? Well, the simple way to do it...
Actually, you can now. As of the May update, you can create measures that return images.
Okay, so you can do that. Coming next month, Paul Turner, excellent presentation on how to.
I'm just glad you brought that up.
Yeah.
So the simple code for that is just this: total sales, and then Dimm products year equals 2017. This snippet of code right here produces this table. Okay, this produces this table, which it adds to the filters, and that's how it gets it just right.
Can I just say for those of you that are struggling to say this, you probably typically see calculate total sales in product. Just so you know, this does work without that particular syntax. So many of you probably have been introduced to it. If there's a reason that it works, but
Yeah.
most people probably wouldn't have seen that.
So questions about this, up until where we're at right now. Okay. So
is 2017 sales the name of the measure in
Yes.
this example?
That's right. Yes.
And so why do we add an override filter for 2017? Because that's the name of the measure. That's what it's supposed to do. A good portion of DAX is saying, what did I call this measure? What's it supposed to be doing? Oh, it's supposed to be doing this. What's my job? I have to go set the filters just right to answer that business question. Okay? Okay. So you can take this in a lot of different directions. If you want to imagine simple override filters, or any override filters, you have to think of them as tables, right? If I want 2017 sales, how do I get it? I go get total sales with an override filter for year equals 2017. If I want Portland sales, I go get total sales with an override filter for city equals Portland. If I want Beaverton and Vancouver sales, I go get total sales with a table that has city, Beaverton, and Vancouver, right? You can sort of see how this works. And whenever you want to have one of these override tables, you have to think in your head, how do I get a table that looks the way I want it to be? Okay? Don't just stop when you get to the business logic. Don't just say, I need to see all the days year. I don't need to see days year to date. Okay? Once you get there, you have to move forward and say, all right, now that I know what I need to get, how do I show that as a table? Because you can't tell DAX that filter unless you tell it to it like it's a table. It's the only language that DAX speaks. Okay? So we've talked about one of the filter refiners. There's three major ones that you'll use in DAX. There's more, but these are the ones that you will use most often. Okay? Any measure is a filter refiner. Again, how do measures work? They refine the filters and then they run their code. The other major filter refiner that a lot of people in this room have probably seen is the calculate function. What does the calculate function do? It refines the filters and then it runs the code in argument 1. Okay? How about calculate table? How does it work? It refines the filters and then it runs the code in argument 1. The difference between calculate and calculate table, anybody happen to know? Sort of in the name.
One returns a
Tables, a table.
table, one returns a scalar.
Yeah, exactly. So if all you got to do is return technically the term for it is a scalar, but you think like a number or a date, you just use calculate, which is the one you'll use most of the time. If you have to ask a question that returns a whole table, right, but you want to refine the filters when you do it, that's when you use calculate table. Okay? So we've got three things right here, and all three of these things have the same fundamental behavior. They refine the filters and they run their code, which means they all three of them, automatically perform current row filtering, and if you want to, you could add optional override filters that they add after the current row filtering. And then once they've done both of those things, they run their code. So on this screen, you may notice that measures and calculate look an awful lot alike. And I would say that's because they are a lot alike. So one way of thinking of a measure is an official version of a calculate statement. Or if you want to switch that around, one way of thinking of the calculate function is a way to have an informal measure. But they all basically do the same thing. Again. They refine the filters and they run their code. The difference between a measure and calculate is with a measure, the code is defined in the model. With calculate, it's just whatever you write in argument 1. Okay? Questions about this? Okay. So, get my mouse back.
So Brian, when you speak about measures, with this implicit sort of calculate, I mean, you don't see that much out there, people writing about that or talking about it in that way.
Yeah, so one of the, I found confusing things about measures when I was trying to learn them, they just seemed like a place where you would put a snippet of code that you wanted to run. And it's true they do that, but then as this sort of afterthought, if you got far enough along, it would say, oh, and by the way, one of the other things that measures do is they engage context transition, which is to say they do current row filtering, which is to say they refine the filters. So in my mind, like that's, if not equally as important, maybe more important. That's the most important part of a measure, is before it runs the code, it's got to refine the filters. That's how you get the right answer. Yeah? Okay, so we've got Act 1. Again, just to review. Summary tables are the fundamental things the DAX engine builds. DAX works by making derived tables from the data model, and DAX even filters your tables. Measures correctly answer a business question by using filter refinement. They start getting filters correct by performing current row filtering. They finish getting filters correct by applying optional override filters. Okay? Then they run their code. Okay, so let's talk about iterators. What is an iterator? Simple. An iterator gets a copy of a table, adds an expression column to it, then does something with it. All iterators do the same thing, those 3 steps. Okay? SumX sums up the new column, average X averages the new column, and max X gets the biggest value, and so on and so forth, right? So if I've got a measure right here called average product line sales, how does it work? It uses the average X function. So what does it do? It gets a table, in this case, all of the visible product lines, values, Dimm products line. Here's all the visible product lines. Then it adds a column to it, an expression column. What's the definition of that expression column? Argument 2 right here, total sales. This is total sales for coffee, total sales for latte, and total sales for mocha. And then what does it do with this new expression column? It averages it. Why does it average it? Because it's the average X function. Because I told it to. If I wanted the max, what would I use? Max X. If I wanted the sum, what would I use? Sum X. If I wanted the median, what would I use? Median X. They all do the same thing. Take a table, add a column to it, do something with it. What's the thing you do with it? Whatever the name of the function is. What's the table? Argument 2. What's the new column? Argument 3, or argument 1 and argument 2. Okay? All work the same way. Does that make sense? Okay. So, if all you do is change the table, you get wildly different results. If we look at these 3 measures right here, I've got average city sales, average store sales, all stores. The only difference between these 3 measures right here is what table I'm asking for. In this case, I ask for all the visible cities. In this case, I ask for all the stores. And in this case, I ask for all the stores, visible or invisible, right? And for every single one of them, what do? They take a table, add a column to it, and average that column. And that's why I get 3 different numbers, here, here, and here. Okay? Making sense? Okay. So the filter function, it is an iterator that builds override filters. That's what it does. You may think of the filter function as filtering a table. Don't think of it as filtering a table. Think of it as building filters. Remember, in DAX, filters are tables. How do you get those tables? You use the filter function. The filter function builds override tables. Okay? So if we remember, back here I said, hey, how do I get 2017 sales? I go get total sales with an override filter for year equals 2017. How do I do that? Right? The code for this, the more correct code for it, looks like this. 2017 sales is total sales with an override filter. What's the override filter? It's this filter function, this iterator right here. What does this thing do? Gets a table, adds a column to it, and brings back the rows that are true. Okay? So what's the table that it gets? It gets all the years, visible or not, because we're using the all function. It was all the years right there. Okay, now it adds an expression column to it. What's the expression column? Year equals 2017. For this row, that's false. For this row, it's true. And for this row, it's false. And what rows do I bring back? Just the true one, 2017. That's how I get that override filter for year equals 2017.
What's the advantage of doing that instead of just a calculate formula?
It takes up less screen real estate, is one of them. You could argue it's the same thing. So measures use an implicit calculate function, right? So when you call a measure, it's always calling calculate internally. This is a way to basically just not have to write the calculate function.
But if you're just thinking about typing,
Yes.
calculate would be more efficient than that.
No, I mean, so let's see. How
Total
would I-
sales, 2017 sales equals calculate total sales where year equals 2017.
Yeah, so what I could do that would also work, let's hope that Control Z works after I do this. I could replace it. Yeah. I could replace what I had right there with this statement right here, and it would work just as well, right? Which is sort of the same version of what you were talking about with calculate, right? So I could say total sales and then have an override filter for year equals 2017, okay? And when I get to point 9, what I will point out is this statement right here is actually this right here. It's syntactic sugar for it. So when you write dim date year equals 2017, Dax immediately translates it into this bit of code right here. That's what it's doing. But I feel like I dodged your question.
Yeah, I'm just wondering if there's an advantage to doing this over calculating. I'm not seeing that advantage.
So as far as I know, there is no performance advantage to it. There is the advantage in my mind. Okay, so let me just copy this over to Notepad and tell you why I don't actually teach it this way because everybody else does it the other way. But here, let me defend my position here real quick. Okay, so let me just get these guys over here. So let's do it sort of this way. Calculate total sales, and to make these things equal, we would do this right here. I was kind of hoping when I copied it out, I wouldn't have all that junk, and I do. Sorry about that. Okay, so let's see. This is the most interesting part of the presentation, me cleaning up the code. Okay. All right, I'm going to delete this stuff right here because we don't need it no more. I've already got plenty of stuff to work on. Okay, so make sure I get this right. Yeah, these two statements are the same, right? One uses calculate, one just uses total sales. Okay, so up here, I say total sales with this override filter, right? And it works just fine. Go get the total sales with this override filter. Here, which is the way you'll see it in most books, I say calculate, go get total sales with this override filter, okay? So why would I do this as opposed to this? I would generally do this because everybody else I know on the planet Earth tends to write it this way. The advantage to this in my mind, right? How many filter refiners are in this statement right here? How many measures? Let me ask the question. How many measures are in this statement right here? Just the one, right? I call total sales, and that refines the filters. How about down here? How many filter refiners do I have? 2. Calculate refines the filters, and then total sales refines the filters. So what I'm trying to do is modify the filters, and here I'm doing it twice. Once with calculate, and once with my measure call. So I don't think it degrades performance. I'm sure the query optimizer removes that second, what do we call it, filter refinement. But you are asking for the same thing twice.
The other thing is maybe you were thinking, like, if you just were to do a third version, which is literally calculate.
Try this.
Yeah.
You don't need that. You don't need the filter all. You just
Right.
You don't need it.
Except dim dates
So
here,
what?
particular
But I think this is a really important point.
Yeah.
What he was saying is, this is what Dax always does. What he just erased. In other words, if you see this, it will always be doing filter all always has to have the all in there, whatever that table is, and then saying, you know, that the year equals 2017. That's a really important, this is literally syntax sugar, that's it. So when you're trying to understand what Dax is doing, it's helpful to have that larger filter thing going on, which is the reason I think that you.
Yeah, I know, a lot of this stuff, it makes a lot of sense once you've been staring at it for 6 months. But yeah, it can be kind of tricky. So like in practice, I tend to write these things like this, right? As an advanced user, I do this because I know what this is doing. As a new user, the tricky thing about this is how does this work? Fairy dust, magic. Who knows, right? It just works. However, the filter version, that's more mechanical. I say, oh, I get it. I go get a table and I reduce the number of rows and I use that as an override filter. I could see step by step mechanically how that version is working. This one I just have to take Dax's word for it, that it's doing what I want.
Or if you were a SQL developer, you might think, okay, I'm going to get this aggregation and the where clause is the date equals 2017. That's more intuitive to a SQL user.
That can be misleading though, because you start thinking in table scans and indexes, and that works only to a point.
Exactly.
Yeah, so
I think the best reason to use the first form of that is just to really screw with the minds of your colleagues.
Oh yeah, the very first form where he doesn't even put a calculator on it. Yeah, that's.
Brian showed that to me one day, and then I said, I'm going to go screw with Rachel. and I said, I bet you didn't know this worked.
Yeah. Like,
and she left early that day.
So
yes.
I know that your filter columns are either dates or numeric. What happens if you're filtering by a string? And anything different that you need to do? No?
No. Oh, I mean, you have to wrap it. So let's say that somebody was bad and cast year as a text string. You just do that right there. In fact, let me do it over here where you can see the whole thing. Let's say that the year column in Dimm dates year is text. You would just do that right there. That's all you'd have to do. Okay. And again, one of the things I like about even if you never ever use it again, why I think it's worth practicing to sort of wrap your head around it. I think what using the total sales version as opposed to the calculate version, it really sort of pounds into your head that a measure doesn't just run code, it refines filters, right? That one of the things you can do with the measure is alter the filters. In fact, it's not one of the things, it's arguably the most important thing you could do with the measure is modify the filters. You can do it either way, there's no performance hit, but I think if you write things this way, even for a little bit, you start to understand better what a measure is.
If you were to put that on, like you had years on rows that weren't 2017, would that show a blank value or would that show the total sales for 2017?
Show the total sales for 2017.
So that's, but the other version, would it show any value?
The one with the filter?
Yeah,
all?
Filter all.
It's the exact same code.
It's the same code, but it's a really good question because if you took the all out,
right,
it would just show that, you know, it would
wouldn't
blank
show
for everything that wasn't 2017.
But if you have the all in there, it's going to show the total sales for 2017, even if it was 2018.
Correct.
Yeah.
But that's a really tricky thing that a lot of people get stumped on, you know.
So let me ask the question, right? Looking at this screen right here and this code, if I did filter, instead of doing filter all Dimm dates here, I did filter values Dimm dates here, what would this table look like? You know, always ask yourself, what does a table look like? It looks like this, but what? If we're only looking at, oh, I guess we don't have anything filtered. Let's imagine that we've got years on rows, and we're looking at a row that's 2016. If I ask for all the visible years in a row for 2016, how many are there? Just the one for 2016. So rather than iterating over all 3 years, I would just iterate over 1, which is the same year of the table, which is why I would get gobbledygook. I'd get nothing. Make sense?
Yeah.
Okay.
You were asking a question about different data types. What if it were a date or a number? Is the question you're leading to which is more efficient?
No, I was just wondering if the you've got to do anything different with the syntax rather than just wrap the quotes around it.
That's it.
You know?
Yeah.
However, what's interesting is that though it probably could make a very marginal difference to compare strings versus numbers versus dates, and dates are numbers internally anyway, but the difference isn't that significant.
No.
In SQL, we're taught the data types are everything.
Yeah.
Always use integers, always use small integers. But here it doesn't matter that much because internally everything's pointers and numbers anyway. It's just way down within the engine.
Mm-hmm. Absolutely.
Yep.
Okay, I feel like I'm already taking up too much time, so I'm going to keep moving on this. Any questions about this before I move on to the next one? Okay, so filter builds overrides. Okay. So if I want to build different overrides, I just use different versions of the filter function, or different implementations of it, right? So here I say, hey, I want to go get I just want to look at Portland. So how do I do it? I go get all the cities. I add an expression column that says, is that city equal to Portland, right? And I get true for Portland and false everywhere else, so I just get city equals Portland. That's how I get that override filter. What if I just want to look at Washington? How do I get that? I do a filter for all these states, right? Not all the visible states, all of them, right? And I add an expression column with this expression right here. State equals Washington. For Oregon, that's false, should be. And for Washington, it's true. So what do I get back? State equals Washington. I can also do a filter for all Dimm stores. So all the columns in the stores table, and I say, hey, I want to bring back all the rows where the city equals Portland, right? So if I zoom in real here, right? Where does the city equal Portland? This row right here for Portland State, and this row right here for the Pearl District, and this row right here for division. Okay, for everything else we get a false. So this is the override table that I get back. Okay, does this make sense? Okay, let me ask, I think I'm running out of power. Let me ask a question. Yep. Hold on, I'm going to run and get my power real quick.
I would just say one thing while he's gone, which is that the real reason that all the tables are so important, the real reason the whole engine is created is that you can tell stories with data, because to get those kinds of visuals built fast, because every single one of them is a summary table that is kind of looking like a scatter chart or looking like a bar chart. So it's the interaction and complexity of that can only happen with an engine that does these summary queries really quickly.
Okay.
So that's really the whole, to understand these summary queries, it's like a part of the DAX platform, and the heart of the DAX platform is to be able to deliver visuals that tell a story. You can't try doing this in Excel. You would never get the speed because it's a table-based world, which allows for a whole different kind of speed. Pretty good.
Thank you for killing time, Rachel. I appreciate that. Okay, so let me ask the question. If I use this as an override filter, what am I overriding? State equals Washington, right? How many columns am I overriding? Just the one. That's all that's in here right here. If I come down here, how many columns am I overriding? Just one? Nope. Oop, where's my mouse? One, 2, 3, 4, 5. Even though in my expression right here where I say city equals Portland, I'm only talking about the city because I'm getting a table that's all the columns of Dimm store. My resulting filter has an override for store code, name, layout, state, and city. Okay? It's meaningful. Okay. So, lastly, which we talked about before, I've lost all the thunder here, right? Aggregators and simple overrides are just iterators. Okay? So if you've got a basic aggregator, like sum of sales amount, as far as DAX is concerned, it's sum x sales, sale amount. Okay? It's not similar, it's the same thing. When you write this, DAX immediately translates it to this, because it would have no idea how to implement this. It doesn't make sense in DAX until it gets translated to this right here. Okay? So, if all I want to do is sum up the sale amount column, what are you actually doing? You're getting a copy of the sales table, you're adding an expression column to it with this formula right here, and you're summing up that expression column. So you're not actually summing up the sales amount column, you're summing up the expression column. Now, if you're brand new to DAX, you could just use this and that's just fine, right? Why make your life complicated? But if you want to understand how DAX works, you have to understand that DAX only works in terms of iterators. Now, at first, this might seem like bad news. It's one more thing I have to learn, right? But here's the good news, right? How do I understand aggregators, simple aggregators like this in terms of DAX? I don't have to. There's no such thing. There's only iterators. That's one less thing that I have to understand. Okay?
Likewise,
It's interesting that in DAX 101 we teach, because the effect is the same as it takes the column
Yes.
and adds it up.
Yes.
It doesn't deal with it row by row.
right.
Though under the covers it really does.
Under the covers it does, yeah.
So it's kind of a question of which version of the truth you want to believe.
Well, it's also a question of like how good do you want to get at DAX? If all you want to do is simple aggregations, pay no attention to the man behind the curtain, right? Use the top version. It works just fine. It behaves exactly like you expect. But if you start asking yourself, well, how does this thing work, right? It works by using an iterator, because there are no aggregators in DAX. They don't exist. only iterators, right? Likewise, if I use, right here, I've got total sales with an override filter for a year equals 2017, right? This statement right here is immediately translated to this right here. So these simple overrides that a lot of you have probably used out in the field before, those are just iterators too. How do I understand this complex idea? How does it work mechanically? It's just an iterator. We had 3 concepts before we got to this page. Now we have 1, just iterators. Okay? So, if we come back here to this page, what we find is almost everything in DAX is going to be built from a combination of derived tables, measures, and iterators. Okay? So, to derive these tables, right, I just use simple table calls. I can use all Dimm store state to get state table. I can use fact sales to get the fact sales table filtered, right? Where do the filters come from? Well, those come from these iterators right here. And it comes from this iterator right here. Okay? So what I'm trying to get at, I'll just skip forward to the last bit. Skip forward to the last bit. 95% of DAX is on this page. Don't worry, it's still hard. Okay? Summary tables, they create summarizations of the data model for a visual. These are the fundamental things that the DAX engine builds. They have category columns, which correspond to business contexts, and they have measure columns, which correspond to business answers. You get to define how the measures work. You set how those things work. Okay? So how do we build these summary tables? We build them with a combination of filter refiners, derived tables, and iterators. And that's it. That's all we do. Okay? How do filter refiners work? They refine the filters, then they run their code. What are the main filter refiners? Measures, calculate, and calculate table. They always filter the current row, and they can have, if you want, optional filter overrides. How do derived tables work? You get a derived table based on the table in the data model. You can ignore the filters or respect the filters. You can get all the columns or just a single column, right? And once you've got that derived table, what do you do with it? Well, you could pass it back to a filter refiner as an override filter if it works just like it is. You could also say, you know what? That derived table, that's not the filter that I want. I have to change it before I get it in the shape that I need it to be in. So what do? You use an iterator. You use an iterator like filter to say, hey, I want to reshape this derived table to look the way I want so that it's the correct override filter. Or you could say, you know what, the filters are just fine. I'm going to go derive a copy of my sales table and then add an iterator for sales amount and sum that up to get the number that I need. Everything you do in DAX is just filter refiners, derived tables, and iterators. And if you want to, you can reshape it just a little bit like this. Okay? So this is basically like almost a taxonomy of DAX, right? So what does DAX do? It builds summary tables. How does it build them? By using filter refiners, which modify filters. By deriving tables. When you derive a table, you use those filters. And once you've got that, you can use table operations to convert a table either to a number or another table using what? Using an iterator, right? And by the way, I don't really mention it because it's so obvious. When you're doing these iterators in the columns, you could use simple math, right? And so for completeness, I added that as a column right here. So it means you could do things like 3 plus 5/8. You could round numbers. And also, when you're using an iterator, you can also do things like sale quantity times sale price if you're in the sales table, and it works just fine. Okay? So I would argue that most of the stuff that you can do in DAX all fits tightly into this right here. So if you can understand this, it doesn't make you a DAX expert, but as you move forward, you sort of see where everything goes and see where all the pieces fit. Okay, I think I've talked too much.
Yeah. I think we got only a couple minutes for questions.
Are there any questions?
Thank you again for blowing our minds.
Happy to do it.
I think there's a question right.
Hopefully some of the things I told you were accurate and true. At least a couple of them. Yeah.
So is there an order for this? Does it something happen first, then followed by second?
Yeah, so one way I like to describe this is if DAX were a video game, these are the 4 buttons that you could hit on the video game. Whenever you use a measure, so when you add a measure to a summary table, right, the first thing a measure always does is refine the filters. So this always happens first. It can happen later too, but this is always the first thing that happens, right? Refine the filters. Then when you refine it, you can do any of the other 3. You could say, measure 2 plus 2, and then it just does regular math. Or you could say, you know what? I want to, with those refined filters, go get this table and add a column to it and sum it up, right? So you refine the filters, you get the table, you add the expression column to it, which uses the regular math, and then when you're all done, it returns just a number. That's what measures have to return. So you always start here. You always kind of end up on regular math because you have to return a single scalar value, measures do. Okay.
All right. Well, in the
Yeah.
interest of time, let's give Brian
Great. Thank you very much. Thank you for your time.
Awesome. We'll give everybody a 5-minute break.